Hey everyone, and welcome. Today we're going to talk about stuff. No, really. We're diving into the story of the actual materials that have built our world. Everything from the first stone tools all the way to the silicon ships that are probably in your pocket right now. It's an amazing story about how our ability to make and manipulate materials has literally defined civilization. So let's get into it.
So let's start with a really big question. When you think about all of human history, what is it that really marks our progress? Is it the empires we've built, the ideas we've had, or is it maybe something a little more physical?
Well, for almost all of our existence, the answer was pretty obvious. The major eras of human history are literally named after the material that was king at the time. You've got the Stone Age, the Bronze Age, the Iron Age. Our ability to find and use new materials was, without a doubt, the engine of progress.
All right, so let's start our journey right there with the stuff that actually made history. For thousands and thousands of years, our progress was a slow, painstaking process. It was tied directly to our ability to work with whatever nature gave us, rocks, metals, wood. We just slowly learned how to shape them for our needs. This was really an age of discovery, not invention.
And then, things started to speed up. A lot. The 20th century kicked off a completely new era. An era where we stopped just finding materials and started inventing them from scratch.
I mean, just look at the pace of innovation here. It's wild. In just a handful of decades, we got fiberglass, the silicon chip, bioceramics that can actually fuse with human bone, and special tiles that could protect a spaceship as it re-entered Earth's atmosphere. The game had totally changed. So let's take fiberglass. It was actually invented back in 1938, just to be insulation. But once we figured out how to mix those glass fibers with plastics, bam! It became this super versatile composite material that's in everything from surfboards to boats to cars. It completely changed manufacturing.
And then came the next huge leap. In 1959, a couple of engineers, Jack Kilby and Robert Noyce, they were working separately, but they both figured out how to build an entire circuit on a tiny little slice of silicone. This single invention didn't just create a new gadget. It literally created our entire digital world. And our ambitions just kept getting bigger. Just think about the space shuttle. It needed to survive these insane temperatures coming back into the atmosphere. The solution? Over 24,000 custom-engineered ceramic tiles, each one designed for a specific job. I mean, that is a level of materials engineering that would have sounded like pure science fiction just a century earlier.
So the big question is, how did we get so good so fast? Well, we went from just inventing things through trial and error to actually understanding the fundamental rules that make materials work. We started cracking the material code. And the key breakthrough was something called the materials paradigm. Scientists figured out that these four ideas are all connected in this constant feedback loop. A material's atomic structure, how its atoms are arranged, determines its properties. How we process it changes that structure. And all of that together determines its final performance. Understanding this relationship was the key to unlocking how to design materials on purpose. And alongside that big idea, scientists developed these fundamental principles, like the Hume-Rothery rules back in the 1920s. These are basically a cheat sheet, a set of rules that help predict if you can mix two metals together to make a good alloy. And just like that, making new metals went from being kind of a guessing game to a real predictive science. So, once we had that fundamental understanding, it set the stage for the next massive revolution in materials science, what's called the Materials Genome Initiative. And here's why this is such a game changer. The old way of making new materials was just so slow. It was linear, it could take 20 years or more to get from a new idea to an actual product. But the new way, this MGI approach, it's a super fast dynamic loop. You have powerful computers, real-world experiments, and scientific theory all talking to each other all at once, which just massively speeds up the whole process. And the end game here? It's huge. We're getting to a point where we don't have to search and hope we find a material with the properties we need. Instead, we can actually design the exact material we want, from the ground up, from the fundamental laws of physics, for a very specific job. And believe me, this isn't just some theory tucked away in a lab. The U.S. government has poured over $270 million into a program specifically designed to push this new approach forward. That's how critical this is to staying competitive on the world stage. So, what does that future actually look like? Well, it kind of looks like this. What you're seeing are microelectromechanical systems, or MEMS. These are tiny, complex machines with gears that are smaller than a single grain of sand. You can only build something with this kind of mind-blowing precision when you have absolute control over your materials at the microscopic level. So where is all of this taking us? Well, we've come a long, long way. We've gone from basically picking up interesting rocks to literally designing the atoms that make up our world. You can really see the whole journey in these 4 steps. We started with accidental discovery, finding things. Then we moved to systematic invention in the 20th century. That led to a fundamental understanding of why things work, which has now brought us here, to the era of intentional design. This is a fundamental shift in our relationship with the physical world. For pretty much all of human history, the materials we had around us to find what we could do. Now, we are starting to define the materials we need, and then we're just making them. Which really leaves us with one last big thought. We've had a Stone Age, a Bronze Age, an Iron Age. You could even call our time the Silicon Age. But if we can now design any material for any purpose we can dream up, what do you think the next great age of human history is going to be called? Thanks for watching.